I haven't read any of Lee Smolin yet, though Einstein's Unfinished Revolution is on my list. But so I've read an article that Slavoj wrote. I think it's upcoming in a book next year on quantum theory. But in it,
It's not a book in quantum theory, just one short chapter. Sorry, yeah?
Yeah, just one chapter. But Slavoj paraphrases Smolin's belief that quantum mechanics is the most successful theory ever formulated, but the only problem with it is that it is wrong. And I have the sense that it is at least incomplete in that it doesn't cohere with relativity, so there's no quantum gravity, no theory of everything.
No, it makes a very standard point here, Smolin.
Right. But what I'm wondering is how you gloss this idea, and more relevant to our discussion, is whether the many worlds interpretation is something that's in jeopardy on the road to this theory of everything.
Yeah, there is a temptation in certain circles to, sorry, that's a little too prejudicial. We don't know what the final theory of everything is, right? So each one of us as individual researchers will have our favorite ways of trying to make progress. And this goes back to what we discussed at the very beginning about preferences for different versions of quantum mechanics. Many worlds as a theory is as simple as it is possible for a theory to be. The problem with it is that connecting it to the richness of the world involves some tricky metaphysical and physical steps, right, about which people can be rightfully skeptical. Whereas something like hidden variables or whatever is an ugly, complicated theory, but the world is ugly and complicated, so it matches the world in a more easy way, and you can have different feelings about what to do. There's a third way, which is someone like Lee, who says, like, I don't quite see how it is working right now, therefore I will throw it all out and start from scratch and try to do better. And to me, we're nowhere close to that point yet. We have not yet done anything like trying to understand the world in the quantum language to motivate trying to improve on quantum mechanics. In particular, just to be clear about relativity, there's special relativity and general relativity. Quantum mechanics and special relativity are 100% compatible. That is literally quantum field theory, which is the best tested theory in the universe ever. General relativity, which says that space-time is dynamical and that's what gravity is, it is true. We do not have a once and for all final quantum theory of gravity. But again, to me, many worlds is the most promising route forward for doing that. And if you'll indulge me just for, one more minute here, the reason why I think we are stuck is because even the most highly trained physicist learns classical physics first. Newton's laws, the Kepler's laws, the planets, etc. And then they are taught how to take a classical theory and convert it into a quantum theory, to quantize it, right? And that's what we do with electromagnetism and the standard model of particle physics and all those things. There's no law, rule, or even suggestion that says that the correct quantum theory of the universe has to be obtained by starting with a classical theory and quantizing it. The universe doesn't do that. It just is quantum from the start. And if you want to imagine that maybe that's why it's been difficult to quantize gravity, because you shouldn't be quantizing gravity. You should be thinking about quantum mechanics and finding gravity within it. And clearly, I would argue, I'm not going to bother you with it now, but I would strongly argue the right framework to do that in is exactly many worlds.